Hello Year 6, soon to be Year 7. Today we've got our physics lesson at home. We're going to be looking at factors that affect the time it takes for this car to go down the ramp. You can see the equipment I've got there. I've got a shelf, a piece of wood, anything that's a flat surface that you can change the height of will be perfect. I've got a tape measure, a stop clock, but you could use your phone if you don't have one, and I've got a toy car. Underneath the shelf there you can see I've got some books, and I'm going to use those to change the height of the shelf. So we're going to be investigating whatever factor you would like to investigate to see the speed or the time that it takes this car to go down the ramp. Okay, so let's get to the investigation booklet and do some planning. So here's the investigation booklet, and we've got this big question of how can we make the car go fast. And we're all going to be working on this slightly differently because we're going to discuss all the different factors that could affect the time it takes for the car to go down the ramp, and then you're going to decide which one you want to investigate. Okay, so we've got a bit of a picture there of our setup with the car on the ramp, stopwatch and our tape measure, and that's a time now for you to pause the video and come up with any of your thoughts. What could affect how fast this car goes down the ramp? And you can add your thoughts into that thoughts box there. So it might be a good idea to pause now. Now, we are investigating a car on a ramp, and I've kept that quite simple deliberately because I haven't yet decided what factor it is that I'm going to change to investigate today. So I've just kept it as quite a generic statement. Now, like I said in the biology video, I'm using post-it notes just to speed up so you don't have to watch me writing on the sheet. You write on your pack. You don't need to use post-it notes. It's just for me to quickly be able to go through all of the content with you. So things that we could change. Again, this is an opportunity if you want to bring some of those thoughts, ideas, over onto this page and to jot down some ideas of things you could change. I'm going to annotate with the ideas I've come up with. You might have more. So we could change the surface of the ramp. We could change the height of the ramp, which I've already started to talk about in the introduction. We could change the mass of the car, maybe use a car and then use a truck, something like that. We could change the wheels of the car. Okay, you may come up with other factors. Those are the ones that I have come up with. Okay, and what we could measure or observe, the time for the car to go down the ramp. And if we had some more elaborate equipment, maybe a light gate, we could actually measure, using that equipment, the speed of the car down the ramp. And you'll get to do that when we come to school at some point during your time at secondary school. It's actually a GCSE skill to use a light gate. So what I've decided to change out of those four things is the height of the ramp. Now you can choose to join me by changing the height of the ramp, or if you've got lots of different cars and maybe you can find the mass of them by putting on the scales, you could do that. If you have lots of different surfaces that you could put on the ramp to make it rougher or smoother, you could try that. If you've got similar massed cars but with different wheels, then you could try that. It's a bit of a tricky one, that one. So I'm going for height of ramp, which we call the independent variable. I have independently chosen to change that feature. And what I'm going to measure is the time it takes for the car to go down the ramp. Okay, so my question now is a bit more specific than what I was investigating up here. Our question is, how will the height of the ramp affect the time for it to go down the ramp? Okay, how will the height of the ramp affect the time for the car to go down the ramp? And anything up here that I identified that I could change, I now need to keep the same down here. So if I'm just changing the height of the ramp, then I need to make sure for all of my testing, the surface of the ramp is the same. I need to make sure that the mass of the car remains the same, that the wheels of the car remain the same. And I'm going to add another controlled variable in there, and that is the length of the ramp. There's no point me using a short ramp and then a long ramp. Obviously that's going to change the time it takes to go down the ramp. Okay, so now we go on to our prediction. So when we change, again this is a bit generic at first, when we change the height of the ramp, what we will think will happen to the time for the car to go down the ramp is, and I've just gone basic with this, it will change. Okay, the phrasing of it doesn't allow me to say as the height increases I think the time will be slower, but that's where I'm going with this. Okay, so you can change how you word that if you want. And I've put down here, this is because, and this is where I've given my reasoning, I think the steeper the ramp, the faster the car, and I think that's because of gravity. Okay, so I've got lots of features there. Okay, I've planned my experiment. This is an opportunity now for you to pause the video, plan your planning sheet, plan for your experiment. What are you going to change? How are you going to work it? Don't feel you just have to use mine. Okay, this is an example and then you are going to personalize it for what interests you. You might decide to do several experiments and change several variables as we go along. That's absolutely fine. If you need to use extra paper, make some more results tables and graphs, that's absolutely fine. In fact, that's even better. Okay, so what I'm going to do now is just move this sheet out of the way here and keep the planning one visible on the screen, and I'm going to look at obtaining evidence because I need my results table before I can begin collecting any data. Okay, so again, we've got this, we had what could we change, and we've now decided what we're going to change, and for me it's height of the ramp, okay, which I'm going to measure in centimetres, and I've decided that I'm going to have ramp heights that are 10, 20, 30, 40 and 50 centimetres high. Okay, and I'll show you how I'm going to measure that shortly. Again, you can choose whatever values you want. You can do as many or as few tests as you want, whatever makes you happy. It's all about just a bit of self-discovery with this practical, so it's up to you. I'm going to do each height of ramp 1, 2, 3 times, and then I can find that mean. And what I'm measuring is that time taken for the car to go down the ramp, and that's measured in seconds. I'm going to use my stop clock to do that. So it's now the opportunity to set up our practical once we've done all of our planning, and let's start collecting some data. For the moment, we don't need to measure the length of the ramp. You can see I've got my car here, a classic Citroen 2CV, and I am going to let go of that whilst timing how long it takes from when I let go to when it hits the wall over there. Now it's really important, I'm not tempted to give it a nudge, I've just literally got to let go of it and then start my timer and stop my timer. So here goes. And that was 3.41 seconds. So I can record that on my results sheet. I can then do that 2 more times, and then I'm going to use some more books to wedge underneath my shelf here, my board, my ramp, to take the height of the ramp up. And just to show you there, it's 10 centimetres to the top of the ramp here. Okay, so that's where I've measured my 10 centimetres. Okay, time for you to collect your data, however you've decided to do that, and I'm going to do exactly the same, and then we'll have a look at our results and how we process the data. So I've now carried out my experiment, and it's really interesting because as science teachers, we tend to trial practicals to see that they're going to work, to see that they're going to give us a good set of results, and then we explain how students do those practicals, and then they go ahead and do them. Now, I didn't do that with this practical, and I could say it was deliberate, but it wasn't. But I certainly could not have used the ramp at a height of 50 centimetres because that car just went far too fast. Okay, so as a result of that, if I tried that out beforehand, gone from my lowest height to my highest height, I would have realised that 50 was probably pushing it a bit much. Maybe I could have decided to do some in-between values. I could have gone for 5 centimetres, 15, 25 to give myself a better range of results. But that's called a preliminary experiment. Okay, it's when we do a pre-experiment to see, is this going to work? Is this going to make the car go too fast? Will it roll even on a 5 centimetre high ramp? Those are the sorts of things that we trial before we start to see what what kind of results we're going to get. So 50 centimetres was a bit extreme, so I've taken that one off. But that's what being a scientist is all about. We try things and we learn from it. So looking at those mean averages again, we add our 3 results together. So the 3 results for 10 centimetres high there, and then press equals. That's really important on the calculator to press equals. Divide it by 3, and then we've got to use our rounding skills. So here I rounded again to 2 decimal places because all of my results were to 2 decimal places, and I rounded to 3.87 based on if it was 5 or above I round up, and 4 or below I round down, and this was a round up situation. I think the answer was 3.86. And then the next number was a 5 or above, so I rounded up. Next one then was, so for 20, these are going to start spreading out slightly, but we'll be okay. So for 20 centimetres on the ramp, I had a total of 5.34, divide that by 3, and I got 1.78. And it's really good to know if you've worked out your mean correctly, because your value should be similar within that range of results that you got originally. Okay, next one then for 30, we've got 2.37 divided by 3, which gives us 0.79. Remember, this is in seconds, so it's the amount of time it takes to go down that ramp. And then the final one is 1.16 divided by 3 gives us 0.39 seconds. Now, one thing I can do here to extend it, now if you choose not to do this, that's absolutely fine. You can just record your height of your ramp or whatever it was that you changed here, and then you can do your time taken for the car to go down the ramp here in seconds. But I'm going to take it that next step by using this equation. Speed equals distance divided by time. And this is where that tape measure comes in. Now I've measured from the end of the ramp where the front of the car stopped to where the front of the car started on the ramp. So I haven't measured the entire length of the ramp. I've measured from where the front of the car started. So that was about 9 centimetres into the ramp, and then all the way to the end. And that distance was 90 centimetres, which if I convert that to metres is 0.9 metres. Now that's now important to use this equation, distance, which is the 0.9, divided by the time, which we're going to use these mean averages, to work out the speed of the car at each of the 4 different heights, the average speed that is. So here we go. For 10 centimetres high, there's the distance divided by that mean. So the car at 10 metres high of the ramp was travelling at 0.25 metres per second. So in other words, every second travelling 23 centimetres. Okay, then I look at the ramp at 20 centimetres, and again it travelled the same distance, divide it by that mean, and the car was going really twice the speed, travelling at 0.51 metres per second. So travelling half a metre every second. Next one. Okay, same distance, divide by the mean for 30 centimetres height of the ramp, and we get 1.14 metres per second. Okay, and then the final one at 40 centimetres height of the ramp, same distance, new mean, and the car travelled at 2.31 metres per second. Okay, so every second the car travelled 2.3 metres. Okay, now we can use this information for our graph if we choose to. Okay, now like I said, if you're not happy with what I've just done, maybe it's a bit too advanced, that's absolutely fine. Okay, you can do a graph here of whatever your independent variable was, whatever it was you changed, you can put here, and you can just put simply the time taken here, and you've got your means. If you want to take it to the next level and you want to do a recording of the speed here, again, brilliant, absolutely fine. Either way, whichever works for you is great. Okay, so I'm just going to show you how to do this now. So change was the height of ramp, and that was in centimetres. Okay, and I'm going to go for the speed, which is in metres per second. Now, if I look at my results, I need to go up to probably 2.5, because 2.3 is my highest number. So I plan it out and I think, okay, I could go 1, 2, 3. That fits in quite nicely. So 0, 1, 2, 3, and that's for the speed. And then the height of the ramp, I could go, again, plan it out, could go 10, 20, 30, 40, and then stop there. Okay, probably need a slightly thinner pen. This one's been used a lot and now has become thicker at the end. So this is what we call continuous data. It's numerical values where there are lots and lots of different possibilities. Any number is possible. Okay, so for this, we're not going to do the bar chart that we did on the ruler drop experiment. We're going to do a scatter graph and then a line of best fit. So for 10 centimetres, can you see that? For 10 centimetres height of the ramp, we had 0.23. Okay, probably not going to be able to get the 3 in there, but the 0.2 I can probably get. So 10 and then 0.2 is going to be, now 1, this line here is half, so I would say 0.2 is there. Okay, and then for 20 I had 0.5, so that's there. For 30 I've got 1.14, so call that 1.1 probably for this purpose. And then 2.3 for a height of 40. Okay, now to me that looks like it's going in a bit of a curve. Okay, we've got curves of best fit and we've got lines of best fit. Now a straight line of best fit we use a ruler for, and a curve of best fit, which this looks like it is, will curve like this. Now I'm actually going to use a pencil for this because it's so easy to get this wrong, and if you get it wrong with a pen, it's proves a bit of a problem. Okay, so there we go, the nice curve of best fit. Probably could have come in slightly on that cross, but I'm quite happy with that. Okay, so I'm going to put that just there. Come over to this side again to show you this. Okay, now I think what I might have to do so that I can write on this is just quickly move these bits and pieces. So I'll put these over here. Bear with me a second. Okay, let's take a look at our final page, considering evidence, evaluating, and some extension tasks if you've really enjoyed what you've been doing today. So when we changed, now again, depends what you chose to change, but I went for height of ramp. Okay, so when we changed height of ramp. What happened to, now I can actually call it time taken, or I can now call it speed, because I've done that calculation to convert my results to speed. So I'm actually going to say what happened to speed is a steeper ramp resulted in a faster car. Now I can actually see that from the times, because I can say, well, if it's a short time, it must have gone faster, but I've converted my speed there as well, so I'm quite happy with that. Why did this happen? I don't want to give too much away. I'm going to do some quite basic answers here. You might want to have a bit of a chat at home or do some research to help you give some information, a bit more detail to what you write here. So why did this happen? A steeper ramp had a greater effect of gravity. I'm just going to keep that as my reason. Was the prediction correct? Yes. I can remember what I wrote before. Were there any unusual readings? Now this is when we look for patterns in results. And actually, in this case, there wasn't for me. And the reason for that is that if it didn't work, if the car went off to one side or came off the ramp, or I hadn't pressed it properly, the stopwatch properly, I just didn't include that result and I just went again. Okay, but you might have had the situation where you think, actually it did fall off the side there, or maybe I did press it with a bit of delay. So you might have some unusual readings, but for me, I'm going to say no. I retested when the car came off the ramp, or I was slow to use the stopwatch. Okay. Extension. If I double the height of the ramp, the speed will double, i.e. the time will half. Is this true? Now, you may want to do some more investigating if you didn't do height of the ramp, or you could potentially look over at these results and you could work with that. I'm not going to write anything for that because I want to leave something open for you to have a go at. If I double the mass of the car, the speed will double, i.e. the time will half. Is this true? Again, these are things that you could work on, investigate further if you want to. Not telling you have to, but if you have enjoyed what you've been doing today, then by all means have a go at extending your knowledge, looking into more factors that affect the speed. That's the end of our physics lesson. We're really excited to see you in September to do some really good science at secondary school. Don't forget, there's lots of videos on this playlist now, the Year 6 transition playlist to secondary school. There may well be some more investigations coming along over the summer, so keep your eyes peeled. Get the hit the subscribe, and then you'll get some notifications and you can see when new videos go live. Hope you enjoyed yourself. Don't get too stressed if it was too difficult. Just, it's all about having fun. Okay, thank you very much.